Okay, everyone, I think we can get started. So today is on the last lecture, so thank you for pulling up. I know it's a very busy time with like the end of the semester and all, but we'll distribute some like prizes today for participation in like the Kahoot. So we'll do that at the end, but for the main part, we're just gonna wrap up images. Remember that in your hack challenge, you have to implement either authentication or images. So I don't know, whichever one you like better, whichever one you think is like easier, you can feel free to do. So hopefully this will help you with like the images stuff. Just some other announcements to make. You should have received an email from your hack challenge mentor already. If you haven't done so, like either email me or Mateo or like make a private ed post. Make sure to reply to that email by the end of the day today. With all of the action items listed in like the ed announcement that I made like a day or so ago. And then remember that your midpoint submission is due this Sunday. And you need like a completed API specific, like API design, as well as a completed like database file. So yeah, and then your mentor will help you, we'll schedule a meeting with you sometime this week to help you kind of like flesh some of that out. If you need any like help with like your idea or implementing the models that you like need. Yeah, and then the last thing is just any assignment resubmissions are due this Friday. So make sure to get those in if you want to resubmit anything. Does anyone have any questions about like hack challenge or anything before we start? Okay, if not, let's get started. So, I mean, on Monday, what we went over is we went over, how to store images in a database. We use this base64image.de website to convert an image into a base64 string. And then we uploaded it into, there was like a small demo of like what the completed app looked like, where we uploaded it into our AWS buckets that we set up, something like this. And then it gave us a URL back, right? And that URL, when we clicked it, we could just download the image. So today we're just going to finish that up. Does anyone have any questions about what happened on Monday? Okay, if not, let's go into db.py. So last time we left off at implementing this asset model. We implemented the initialize function where we initialize this asset object. And then we call this function create, which actually like, creates the image for us essentially. So we're going to continue by implementing that function. So let's create the function create. Takes in self and some image data. And that image data is that base64 string that we pass in. So give it some documentation. Given an image in base64 form does the following. So one rejects the image if it's not supported file type. So remember up here, we defined all of our supported file types. If it's not that, we want to reject it. Two, generates a random string for the image file name. Remember when we uploaded it and we got the link back and we downloaded it, the image name of the file was no longer the same as it was before, right? Originally, it was like bugcat.kapoo.png, but then it became a random series of capital letters and numbers, which we do because we want to protect any sensitive information that may be in a file name. And then three, decodes the image and attempts to upload it to AWS. Okay, so to start this function off, we want to wrap it in a try-catch block. Why do we want to do this? So essentially, just as I guess like a refresher on the concept itself, the try-catch block essentially executes the code in like the try section. And if at any point the code in the try section throws an error at you, you don't just crash like the entire application, but you like catch that error and you can like print out a message to the user being like, oh, like something funny happened or something like that. The reason why we want to wrap this function in a try-catch block is because we're depending on a third-party service to help with our function, right? We're depending on Amazon Web Services and their S3 storage service in particular to actually store images for us. And our endpoint like hits some of their endpoints in their server, right? So just in case something out of our own control fails, essentially like Amazon, the try-catch block is generally a good option when we're depending on some kind of like outside source. Because if we don't know what's like going on over there, we don't want like, because like their service is failing to crash our app as well. So we wrap this in a try-catch block such that that doesn't happen. Okay, so I guess we start with try. And then first we want to define what the extension of the image is. So if you remember the guess extension import that we did on Monday, guess is the extension of a particular image, right? That's what guess extension and guess types essentially do here. So here we use guess extension, and then guess type, image data. So we pass in the image data such that it can try to figure out what kind of image it is. And then image data at 0, at 1. Or the exact I guess under the hood operations of this function, you don't have to exactly worry about. Just copy and paste this line of code if you want to implement images in your hack challenge. Okay. Next, we want to make it such that we only accept supported file extensions, right? So we only want to accept certain types of images. So now that we have the extension, we can just check whether that extension is in the list of allowed extensions that we've already defined up here, right? So we do if ext not in extensions, then we raise an exception. We want to make this an f string, so extension ext not supported. So remember we talked about f strings last time too. It essentially allows you to just throw in a variable in there, or you can use concatenation too. All of them kind of work very similarly. Next, we want to generate, the second bullet point there is we wanted to find a way to securely generate a random string for the image name, right? If you remember from the authentication lecture and demo, we used something called assault in order to hash out the actual raw image name or raw file name or just raw string and turn it into something else. So that's essentially what we're going to be doing here as well. So assault equals an empty string dot join. So essentially we're going to use the random module here that we also imported on Monday to generate just a series of capital letters and numbers, and then join them together with empty strings such that it's just one very long string. So join random dot system random dot choice. These are just functions from the direct from the random module itself. And then we do string dot ASCII uppercase for the uppercase characters, and then string dot digits for the numbers. And then here is for a wildcard kind of variable or indicator in range 16. So this just essentially means we generate a 16-digit character or 16-digit string every single time. Okay. Does anyone have any questions up to this point? Okay. If not, the next thing that we're going to do is we want to kind of decode the image, right? So the third bullet point kind of splits into two parts. We decode the image, and then we also upload it to AWS. So to decode the image, first we have to remove the base 64 header. So what does that essentially mean? If you remember this image data thing that we the base 64 string that it generates that kind of showed you from last time. At the beginning here, there's data. Oh, thank you. There's data, image, JPEG, stuff like this. That doesn't actually contain any file information or image information for us. The actual image information part begins at the string where it starts with base 64, right? So we want to actually get rid of this part. Okay, so to get rid of that part, we're going to use something called regular expressions. So if you remember, we imported RE from Monday as well. Regular expressions, again, is just a way to categorize certain parts of strings. That's what we're going to use to remove that. So image string. So this is just defining that first part of the string. essentially we're substituting this first part of the string that like looks like this up to the comma, and then with an empty string, so we're kind of like deleting it, of like that image data string that we're passing in. And then image data, which is going to be like the actual image itself, because now we want to actually like decode that base64 string, where we can use the library that we imported on Monday again, base64, to actually turn that from like a string into a file that we would want. Okay, and then we use some kind of like function from like the IO module as well to retrieve the actual image itself. Okay. Does anyone have any questions up to that point? This is just basically pre-processing our string up till here. Okay, if not, then the last part of this create function, we're essentially just going to, set the like the fields when we like, define the class up here with all of their fields, just set the fields themselves. So self.base URL is the S3 base URL, which we defined up here with like our bucket name. Then self.salt is the salt that we created. Self.extension is the extension that we created, ext. Self.width. So now that we also, when we like call image here, we've sort of like converted the image into an image class that like Python can recognize. So now that we have that class that like I guess like our coding environment recognizes, we can actually access attributes of that particular class, right? So that particular class would have like a width field and a height field that we can just access. Image.width and self.height is image.height. And then for the created at, we imported datetime. So we can just use that to give us the current time. Okay, and then lastly, we need to create the file name for the image. So image file name is, we'll use this f string again. So self.salt, which is, the encoded 16-digit thing that we've created with capital letters and numbers, dot self.extension. And then lastly, we'll call an upload function that we, again, haven't defined yet with the image and the image file name. And we'll be defining that in a bit. But then to finish our try-catch block, we'll actually catch an error. So if there's an exception, se print like a helpful error statement. So error while creating image, and then give them the actual error that was generated. Okay. Does anyone have any questions? Okay. If not, the last thing we're going to create in the DB file is the upload function. So let's create a function called upload. Remember, we call that over here. Takes in self, image, file name. And this is the actual part where we kind of like connect to Amazon services and actually like try to like upload our picture into one of their buckets. Okay, similar concept as like the previous function. We want to wrap this in a try-catch block. Okay, so the 3 steps that that are kind of like, I guess, like build up to uploading our image is like, we're first going to save the image on our server locally. And then we're going to upload that image to Amazon services and then make that image URL public. And then finally, we want to remove that image from our own server. Remember in the lecture that happened on Monday, we talked about like, storing images on your own server and then using file paths to access them is also like a valid way to store images in your database, although not the most efficient way. Because if your server goes down, then you lose those images. So we just want to kind of like maintain that concept and keep our servers clear of things that we're going to delegate over to AWS, which is why we want to, again, delete it at the end. Okay, so let's start by saving the image temporarily on the server. We're going to define the actual like location for the image, the temporary location. So image.templock is, again, using the f string. We want to use the base directory that we also defined up here. So we're saving it like at the base kind of like folder on our server that you might remember from like the deployment lecture and demo with the image file name. So this is essentially us creating our own file path on the server for this particular file. Then we want to save that location. Next, we'll upload the image to the S3 bucket. Here we'll like establish the client using the library that we also imported called Boto3, which mentioned on Monday is the actual thing that allows us to like connect to Amazon's API. So boto3.client S3. And then we're going to call one of their functions to help us essentially upload our image to their servers. So S3 client.upload file. So we want the temporary location of our image. So, to define like which image in our server that we're first trying to upload. The bucket that we're trying to upload it to. And then also the name of the file. And then we want to make the image URL actually public so we can like access it and kind of like download it as we saw on Monday. So first we define something called SC resource. It's just some like resources that Amazon offers to help like make these services possible. And then we need to change some particular like credentials on Amazon in order to, or like, I guess like on the S3 servers in order to like ensure our images get public. And the lines of code to do this are just as follows. To specify like this particular image in that particular bucket. And then here we actually like change the credentials. Okay. And then lastly, we want to remove that image from the server, as mentioned a little bit earlier. So we just call our operating system to get that file out of here. Okay. Does anyone have any questions on like these steps essentially? Okay. If not, we'll catch the exception and then move on to app.py. Okay, so that's it for db.py. Very similar to some of the like PA4 that you've like done in the past. We essentially create an entity for like an image that we call asset, define some like fields for it. We essentially create the image, we like pre-process it and turn it into an actual image class such that it can be uploaded to the server on AWS. Okay, let's hop into the app.py file. So for the app.py file, there's only like one endpoint to implement, and that's upload. So if you're implementing like images in your actual app, you'll have like all the other endpoints, and you'll have an endpoint for uploading. Oh, before that though, there are some things that we need to import. So we import DB, and then we also need to import the class that we define. So import asset, and then the rest you've definitely seen before. Okay, so to go into the upload endpoint, very similar to like CMS that you programmed, there's a request body, right? When I pass it into Postman, I give it a JSON with a field called image data. So from body, we want to load in that request data, request.data. And then the image data is body.get image data. We want to check if that image data exists or not. So if image data is none, then we return failure response, no URL, no base64 URL. Otherwise, we can go ahead and create our new asset object. So the asset, we initialize the class with the image data equals to the image data that we just pulled in from the request body. And then we ask the database to add that into its like data collection. And then we commit, like we press save. And then finally, we want to return a success response. But if you remember from previously, we want to like serialize like our success responses. So we need to go ahead and define that in db.py, which I forgot earlier. But back in the day, remember you had like serialize and simple serialize to actually make the output pretty for us in Postman. So I'll define it here underneath init. So just to serialize an object and turn it into like a readable dictionary form. We just want to return a dictionary. If you remember from this like example here, we return a URL and like a created at. So for the URL, it's just the so we have the actual base URL, the salt, and then the extension. So self.base URL, which is like the Amazon sort of like server thing. And then the salt is the actual like name of the file that we have censored. And then the extension, which is the type of the file. Comma. And then it was created at, since we already like made a datetime object out of that, we can just turn it into a string. Okay. So now we can call that here in app.py. Serialize this asset, and then 201 because it was a post request and something was made for us. Okay, that should be it. And then here, remember, last time we also defined a set of environment variables for the bucket name, and the two access keys. So I'll test, I guess, like this app locally now. But first, I need to source in my environment variables. If you don't have like DRM, a way you can also source in your environmental variables is to make a file called like envrc, and then just execute the script. So I'll write 3 export statements. And then go in here. Oh, where'd my cursor go, bruh? Okay, and then you can run this .envrc, which should source in. Hi everyone, welcome to a re-recording of the last part of the 8th demo. There was a slight mishap in lecture. Somehow I couldn't get the AWS to properly like authenticate myself to actually use their storage services. But the bug has been found, and the code that was actually presented in lecture is completely correct. The only small error was like I wrote boto.client here. So make sure whenever you're calling boto3, which remember is the resource that allows us to directly access the AWS servers and actually use their services, make sure you're calling it as boto3 as opposed to just boto, which I made a typo on. But the reason why the bug happened in lecture was just a misnaming of environment variables. So be very careful to make sure you name your environment variables right if you decide to use images for your hack challenge. So if you remember, I made an env file and an envrc. The M file contains like all of the credentials needed to like log into my AWS account. For example, it has like this access ID key and this secret access key. However, the issue was that I exported the name wrong. So here, instead of typing AWS access key ID, originally I only had AWS access key. So then when I sourced in like my environment variables, obviously the credentials didn't work because what it was looking for was AWS access key ID, but it couldn't find that. It could only find AWS access key. So something really interesting about this function, actually, this boto3.client function, is that it actually automatically scans your environment for the right credentials in order to log in when you don't provide it any other arguments. But you can also provide it other arguments, other parameters here, for example, like AWS access key ID, and then provide it a hard-coded string such that it can try to use that to log in for you. Obviously, don't actually put the raw string into that hard-coded parameter because that would be exposing our like secrets. But that is also a way you can, I guess, like authenticate yourself. But if you don't have those parameters, then it will look for that in environment variables. And because I didn't set the name right, there were some problems there. Yeah. So just a refresher to actually like get those access keys. Remember, you want to go to this management console, click your username here, and then go into security credentials. And then you're able to get two of these access keys. So right now in my envrc, I have like one of the active access keys, like this one, and then the secret access key that goes along with it. So I've just sourced in my envrc file, as you see in the terminal. If I do print m, I can see all of the environment variables that are active right now. And that's, so the bucket name is Joyce Demo 8, and then these are my credentials. And then if you remember going back to the actual services, we have one of my buckets is Joyce Demo 8. So yeah, let's kind of show how this works. The rest of the code that was printed in your lecture is completely fine. So you can use this for your hack challenge if you would like. So if we go to Postman, if we run the app locally, we can hit the endpoint here. I was testing it before with a different bucket, but this is still the Buckcat Kapoo image. And if we hit send, we get a link. And if we click this link, we get a download. This download is that Buckcat Kapoo image. We can also do the same thing with containerizing our application. So let's try it, Docker building and then Docker composing up our application. To make sure this actually works, we need to specify the environment variables file on our Docker compose. Also, let's give our image a name as well. So let's call it like Joyce Demo 8. And then the M file is .env. So here we can run Docker build Joyce Demo 8. Oh, sorry, I need to build in the current directory, so make sure to add a period. Wait for the requirements to run. And then let's do Docker compose up -d. Okay. So this should be running on our localhost endpoint, right? Which is this endpoint specifically. Note that I have already shut down like running the app locally on my computer. And we're now running the container through Docker. So let's see if we get a similar result. We go into Postman, hit this again. We get a new link with a new time. If we hit this, again, an image is downloaded. And this time it has like a different name because every time we're randomizing the image name. Okay, the last thing that we want to just quickly run through is deploying this little app that we built here. We can deploy it, and if we hit the same endpoint, then what happens is that we'll still get that same image back. And that's exactly how the front end is going to end up interacting with this part of your app. They'll hit that deployed endpoint, and they'll be able to get an image back to the front end to display. And so if we go back into our code, I'm just going to change this to that. And then we want to do Docker build with the actual platform to ensure that it's like the same on our server. So Docker build platform Linux AMD 64, and then it's -t and then the name. And then everything. So yes, longest part again is waiting for these requirements to run. So we'll patiently await. Just as a refresher, remember the reason why we want to specify this platform is because the server that we use is in this particular OS. So we want to build the image such that it's compatible with that particular OS. If you don't do so, it might work for some systems, but I would definitely recommend to like run that command to be safe. Okay, perfect. Now we want to Docker push. And remember, we want to specify the repository name to push it to. So here is joyceru/demo8. Okay, perfect. Now we want to go into our server and actually pull it down, right? But before, let's refresh this, and we can see that there was a new image that was pushed a few seconds ago. So if we go into our VM instances, let's use this particular machine that's set up here, Joyce Images. Remember, we want to click this SSH button and SSH into our machine. Wi-Fi in this building is indeed particularly slow. Okay, cool. And then here, I've already had like Docker and Docker Compose installed on this. If you want to refresh on how to do that, it's in the demo 6 as well as in the textbook. So we want to just do sudo docker pull choicerwoo demo 8. Remember that you want to have a docker compose.yaml file and an m file on your server. So let's check if those exist. Seems not right now. So let's make a docker compose.yaml file. Let's copy this into the one on the server. And remember, we want to change this to port 80,000 because HTML defaults running on port 80. So this, you might have run into some issues with PA6 to having to append 8,000 at the end of your link if you didn't have this. So exit and save. And then we want to create an environment variables file. These are, they're a little different here for both of them, but I think they're both access keys that I have that work. We're just gonna do this one for now. So for this env file, although I'm pasting in with like export at the beginning, that's actually something I want to delete. Because remember the difference between the envrc file and the actual env file is that the env file just lists out the environment variables, but the envrc file, if you execute it, can actually source it into your environment if you don't already have a program like DRM that sources it in for you. But let's exit out of there, and then we can run Docker Compose up. Okay, so hypothetically, if we go to this link here, if we put this link in the server upload, okay, cool. So now that our container is running, we should be able to access the external IP and yeah, check the I guess our deployed app. So it's this particular VM. So here's the external IP. And yeah, the default endpoint is hello world as defined in, oh, not that one, as defined in this endpoint here. Make sure you have the correct settings on your VM. Make sure you're allowing, like you changed it to Linux and you're allowing only HTTP traffic, or else there might be some issues with getting the website up specifically. But if we take this and then we put it in here, and then we hit the upload endpoint that is associated with this external IP, we should also be able to get something. Cool, let's click this and wow, a new image is downloaded. Oh, this is an old image that was used. But if we use the bugcat kapoo image, that was one of the older images that was, I guess, like used in the course. But if we use this particular bugcat kapoo image and take this entire very long string and put it in here. Yeah, new link, and it's bugcat kapoo again. So yeah, that's essentially how the front end can get your images, essentially how images work. So yeah, thank you all for watching.